Welcome to Enots Engineering. I'm Alan. In today's video we're looking at a 6-inch independent 4-jaw chuck for the lathe. So let's go into the workshop and see how it works. Today I'm looking at the 4-jaw chuck. Last time we looked at the Bernard Grip True 3-jaw chuck. So what I want to do is look at this 4-jaw chuck. I've cleaned everything down, put the wood on the bed so I can rest it there. This chuck is probably a bit big for this lathe, but it works okay. The lathe manages to cope with it. Now this is the Prat 4-jaw. This is a 6-inch independent jaws. You can get 4-jaw self-centering. In other words, each jaw is adjustable. They're not like the 3-jaw chuck where you have a scroll inside. Each jaw has a screw for itself. So let's see if we can take this off and we'll look at the screw. Now, as with the 3-jaw, each jaw is numbered. It says number 1 on there. If you take the jaw out, you can see there's a thread there, and on the inside you have a thread, and it's held in the middle to stop it falling out. This slides on the keyway here and on that slot on the jaws. Here's the jaw number 1 stamped on there, and it says 1 on the chuck. You slide that in, pull it into the thread and screw it down to the required position. As with the 3-jaw chucks, this 4-jaw is located on a back plate, and in my case this back plate was too small for the chuck. About 30 thou had already been machined for a different chuck. So what I did was just put some lines of arc welding across in different positions, and then skimmed the arc welding to the right diameter for the chuck. The chuck's held on by cap heads that are built into the chuck here, and the chuck key is the same size as the cap head. That cap head goes straight the way through the chuck into the back plate and pulls it up. I'll take this one out. That's the type of screw that holds the chuck to the back plate. And when you tighten it up, you need something to hold the chuck. Just tighten it. There are 4 cap heads holding that chuck to the back plate. You can turn these jaws round so that you can hold on an outside diameter. If you turn the whole jaw round, you can hold the diameter with it. So what's the advantage of a 4-jaw chuck? With this one, what I'll do is just move all the jaws using the edge of the jaw as the guide. This gives you some diameters here, and you can see, just roughly set your jaws up to the right position. Now to set the jaws so the bar is running true, use a dial indicator, get the highest reading, tighten the jaw up until all the jaws are adjusted. You may need to slacken the back jaw if the front jaw is too tight. So this can go down 0 there. That's half a thou run out on that. I could get that to 0 if I needed to. Now normally on a 4-jaw chuck you'd use that if you wanted to put some sort of offset on. So if you needed to turn a cam or turn a piece of square steel, you can hold it in the 4-jaw chuck. You can then adjust the jaws by slackening off the one side and tightening up the opposite side. And you're pushing the bar across. So now when I start that up, you can see I've offset that. And in some cases you want to offset, you say, 1/8 of an inch to give you a cam. You can do that on the 4-jaw chuck. Also, because it's got 4 jaws, it can grip the bar tighter than a 3-jaw chuck. You might find with a 3-jaw chuck the bar is still turning. If you're putting a thread using a die, the bar might still turn in a chuck. With the 4-jaw chuck you've got the extra jaw, so it should grip it better. Otherwise you need to go to a collet. So you can true up the part in the chuck. That's useful when you've turned something and you just want to skim it. You can true it up to 0 and then just skim it. Okay, I've taken this jaw out. You can turn it round, put it in, and you can see on the jaw here, normally it's held on this, use this for the diameters. But on the back of the jaw, you've got these diameters there. If you turn all the jaws round, you can hold something up to maybe 7 inches on this 6-inch chuck. Yeah, easy 7 inches. You just have to unscrew each jaw, turn it round, put it back in, and you've got this. It's useful when you're doing a big disc. Locates on the edge and you've still got the face, so make sure it's running true. Now here you can see the retaining part there that holds the thread in, so you can't take this out unless you remove this pin which goes through the back of the chuck. Now you have to take it off the back plate to do that, which I don't want to do at the moment. But each jaw has got a retaining pin that holds the thread in position and stops this part coming out of the chuck. Now these screws are made when I had the hexagon rounded off in the end, and I needed to replace one. I think it was about 5 or 6 years ago. At the time it would cost £80 for one chuck jaw thread. So I decided to make a set, which I did. This is not hardened steel, it's soft steel. They've lasted 4 years so far, there's no problem with them. The hardest part for me was to put the hexagon in the end, but what I did is I drilled it out just a little bit bigger than the minimum size, and then I used an Allen key, ground it, tapped it in until it cut the hexagon. I can't tell you which one it is. I was a bit concerned at first that I thought it might wear out quickly, but there's nothing wrong there. It's lasted 4 years, and I'll put a link to that in the video description. It still works okay. Put the jaw in, slide it into the slot here. As with the 3-jaw chuck, it's got markings on the face to give you a rough idea of the alignment. I use the corner here to align it with the markings. This is an example of a cam that I made for my camera holder that holds the camera over the lathe. So when you see an overhead view of the lathe and I'm turning, this is the cam that holds the camera. This was made in this 4-jaw chuck. That's the chuck key for the 4-jaw chuck. Just a piece of hexagon steel here. I welded it into a hole. This is all turned in the lathe. Makes a simple chuck key. Oh well, that's it for today. Hope that's useful. Hope you enjoyed it. And we'll see you next time on Enots Engineering.